Now actually we are going to discuss the linear block codes. Whatever we have discussed, it was an introduction. Now we are going to discuss a generator and parity check matrix encoding method, how we do the encoding, that we are going to discuss. Block code. In coding theory, block codes are a large and important family of error correcting codes that encode data in blocks. What is the meaning of block codes? See, I want to send a thousands together bits from the transmitter to the receiver. I make them into blocks. Each block I will take and I will encode. Hence it is called as block codes. I will not take a single bit, or I will not do at a time all the bits. I will take a block of bits. A block means what is the size. With the numerical example, we are going to discuss later in this chapter. So remember why it is called as block code. A set of bits we call as a block. We are going to encode those bits are one block at a time. And many types of block codes are available. Commonly used block codes are these. You can note down: parity codes, Hamming codes, Hadamard codes, parity codes, Hamming codes, parity codes, Hamming codes, Hadamard codes, Gole code, Hadamard code and Gole code, cyclic codes. In the cyclic codes, in the bracket we have, you can write CRC, BCH, RS code, BCH codes, RS codes, then non-binary block codes, followed by concatenated block codes, Take another 10 seconds. Those who are not copied, they can copy down parity codes, Hamming codes, Hadamard codes, Gole codes, cyclic codes, in that CRC, BCH and RS, non-binary block codes, concatenated block codes. Let us go to the next. A linear block code is a block code in which the exclusive OR, it's nothing but a mod 2, of any two code words result another code word, then we say linear. Linear codes are traditionally partitioned into block codes and convolutional codes. In this subject, we are going to discuss block codes as well as convolutional codes. So why it is called as a linear? When you exclusive OR any two code word, it will result into another code word. Hence, it is called as linear block code. Take 15 seconds and try to copy down the meaning of a linear block code. A linear block code is a block code in which the exclusive OR of any two code words results into another code word. Let me go to the next. Today we are going to discuss a little theory. Whole encoding procedure we are going to discuss. We are going to discuss decoding procedure without taking any example. So hence sometimes it may feel a little difficulty for you people to understand, but numerical example when you start discussing, definitely 100% I can assure all of you will become so comfortable with all the steps of encoding and decoding. Now read this. I add a parity bit to make a even parity. What should be the fifth bit for the below messages? Actually this sentence was below, hence I wrote above. Now I have changed. I forgot to do this. Now can you tell, for making an even bit, parity bit, the fifth bit I am adding to all this. You can write down the number 1, 2, 3, any 2 followed by whether it is 0 or 1. You have 1 minute time. To make a even parity, I want to add additional 1 bit, a parity bit. For example, first case, whether the parity bit what I am adding, whether it should be 0 or not, such that whether I should add 0 or not, the number of bits should become even. The first case, whether it is a 0 or 1, what I have to add to make a even parity? Type your answer in the chat box. Question is very simple. A total, the fifth position I am adding something. Total 5 bits if I consider. Very good. 1 he is telling, Shankaranand. So when I write here, what he is thinking, if already it is even, I will put 1. No, Shankaranand. Including this what I am writing, together it should become total even. Are you getting my point? Already it is even is there. Hence, I cannot add extra. I have to make it 0. Similarly, can you write 2, 3, 4, any 1 or 2 in the chat box? I think Rashmi has told first one 0, sir. Correct. Can you type a third one, fourth one, anyone? One you can type all of you so that I can go to the next. And for example, 2 is also 0. Correct. And 3, what about others? Rashmi, Vidya. Rashmi is typing. Vidya, Shankarananda. Third and fourth, I want you people to type fast so that you can go. I think Rashmi is typing all. Shankarananda, whether it should be 0 or 1, number of bits should be 1. Yes. So total will become 4 ones. It is correct. I think Shankarananda, and I want one more student to type fourth one at least so that I can understand that you have understood what I told. Let me go to the third one is 1. Vidya has typed. Good. Now, whatever I have just now told, the same thing I have done it here. All zeros, 0, 0, 0, 1, I am adding a 1 because to make a even parity. Simply I am adding 1. So this parity helps us to detect whether error has occurred or not. Correction cannot be done, but at least we can detect whether error has happened or not. Now, a small little example, one more. A horizontal and vertical parity can be taken. For example, I have 4 messages I am sending from transmitter to the receiver. So I am putting a parity bits. Can you tell the first row? I am making even parity, whether it should be 0 or 1 here, what I am appending. Number of 1 should become even. So whether it should be 0 or 1, yeah. I think Vidya has typed 1. And the same way, remaining I can do it. See, this should be, number of 1 should be even. Okay, 1, 2, 3. It should be even means it should be 4. Now I am appending a 1. Similarly, remaining I can do it. And now, whatever I have done, it is for a row. Similarly, I can do it for column. So, for the first column, can you type in and whether it should be 0 or 1? Either it should be 0 or 1. I think Vidya is typing, Rashmi has typed 0. Similarly, here it should be 0, correct. Remaining I am also doing it. Now what I am doing, I am adding a row-wise parity bits, column-wise parity bits. This may help me to do the correction also. How? Let us take one simplest example. Now consider this 1 has become 0. I have sent all these things information from transmitter to the receiver. This has become error means 0 has become 1 or 1 might have become 0. Now 1 has become 0. Now again at the receiver side when I receive, I will check the parity bit, whether all are even parity or not. First is okay, second is okay, but third is not an even parity. 1, 2, 3. Only 3 ones are there. Similarly, if I check the column wise also, only 1 is there. So third column and third row, I don't have even. Remaining all are even. So hence I can say third row and third column is not even parity. Hence third bit of a M3 is in error. This is the way how I can do it. This is not any big algorithm. A simplest how error can be detected. One simplest example so that later we can go for different algorithms. Now try to understand. It's very simple. Whole block diagram, linear block code you can understand easily. Now parity bit I am adding even parity because number of ones become even. 1, 2, 3, 4. Instead of only adding a 1 parity, I can go for more than 1 parity. All are even parity only, but instead of taking all bits, I'll choose particular bit. For example, I will take a first bit belongs to 1, 3rd, 4th. So let me give one simple example so that you can understand. I have made a different color so that you can understand. These bits 1, 2, 3, 4. It should become even parity. Now 1, 1, 1, 3 ones are there. Only considering these 3, I am making a 1. And I consider black color. so it should be 0. Similarly, now I have two parity bits. For a data bits 5. I can have in general something. See, I have a data bit. Parity bits I can take first, second, fifth bit. One more parity can take two, second, third, fourth. Third parity can take first, third, fourth. So now these 5 plus these 3 bits together it becomes a code word. This is a data. These will become parity bits. Together it will become a code word. So let me give a generalized. Yeah, this is generalized. Choosing a parity bits can be generalized. If a message bit is 3 bit, automatically I'll get 2 raised to 3 combination. Those many code words will be there. Above code is a n, k block code. Just copy down this simple information. So that this is standard for this particular chapter. A message bit followed by a parity bits. Together it will become a code word. Always in the beginning I have a message bits followed by message bits. I have a parity bits. Now k message bits are there, so those many code words I'll have. So 2 raised to k code words I'll be having. Okay, let me wait for another 5 seconds and go to the next. Now, weight of the code is nothing but what? A number of non-zero elements contained in the code word. It is nothing but number of ones only. In this example, the number of ones are 1, 2, 3, 4, 5. When all code words have equal weight, means number of ones are same in all the code words, then I can call that as a constant weight code. And I can say systematic code when codes in which the message bits appear at the beginning of the code word. So this you copy down and try to understand. Weight of the code is nothing but a number of non-zero. Number of non-zero is nothing but a number of ones. So in this example, I have shown 1, 2, 3, 4, 5 ones are there, therefore 5 I can. And when all code words are an equal weight, I can say it is a fixed weight or constant weight code. Systematic code is nothing but codes in which the message bits appear at the beginning. So whatever we are discussing now, in this chapter, we write a beginning data bits followed by a parity bits. Together it will become a code word. So such codes we call as a systematic code. Reason is in systematic code, beginning we have data bits and followed by some parity bits. Just copy down. Weight of the code is nothing but a number of ones, and if all the number of ones in all the code words are same, I can say a constant weight code. That's all. 2, 3 words are more than enough in this slide. And throughout this chapter we talk only about a systematic code. Hope most of you have completed, and let me go to the next slide. This we have discussed already. Addition mod 2, and similarly multiplication. Here you have to remember 1 plus 1 equal to 0. And remaining all of 1 into 1 is 1, remaining all are 0. This is known to you people. It's a Galas field you have taken 2. Similarly, I have discussed many. This is a Galas field of 5. Addition table, this is a multiplication table. Even for a Galas field of 7 and all we have discussed in the previous classes. Let me go to the next, as all of you know all these things, no need of any explanation. Now, a linear block codes. A code. A little information may repeat in some of the slides. Again, this information may come again in some of the slide. Whatever is needed that you copy down. We use a mod 2 addition. Arithmetic produces a third code. Then only I can say it's a linear. This is important. Whenever I say n, k linear block code, n represents the code word, K represents the number of message bits, N minus K represents the parity bits. So please copy down this, take a minute. Above you have already copied this information, only this you try to understand. Whenever I say N comma K means what, meaning that you have to copy down. Take a minute, copy down. Hope most of you copied meaning of N, K and N minus K. So let me go to the next. Each message block is encoded. N minus K additional bits are generated. This I have already told in the previous slide. Information sequence is segmented into a message blocks of K successive information bits. What's the block size? K bits. So those I am considering and I am encoding. And for example, let message bits are D equal to D1, D2, DK. Each message bit may be 0 or 1. Again, code word is given by C1, C2, C3 like that. And each bit will be 0 or 1. Total how many codes I will be having? 2 raised to K. Some of the information may be repetitive for you people. Whatever you feel a little additional, that you can just note down. I think here you can take D equal to D1, D2, D3 up to DK. C equal to C1, C2 up to Cn, because number of bits are N. Whether N is a bigger number or K is a bigger number. Can you type in the chat box? N is greater than K or K is greater than N? You can type in the chat box. N greater than K or K greater than N. Any one N is greater. Very good. I think all are active in the class. Why N is greater? Common sense. K bits plus parity bits becomes N bits. So automatically N will be greater. Okay. Thank you for your answers. Let me go to the next. See, this is the way how I do it. A little theory we are discussing. We are not discussing any numerical example in today's class. A theory we discuss. Whatever the theory we are discussing, with numerical example we are going to solve in the next class. So sometimes some students will feel more comfortable with the numerical example. But don't worry. You can go. First we will do this. Then more than not one or two. We will discuss a few examples so that everybody will become a perfect for this. Ck plus 1 is given by P11. Why K plus 1? Because K is already data bits. First parity bit is a Ck plus 1. And how we do it, I told in the previous using different colors. Particular bits I will take. D1, but here I have mentioned all D1, D2, D3 up to DK1. But P11 may be 0 or 1. P21 may be 0 or 1. So like that selected I will make 1 so that only those will be XORed. So that a particular bit will be decided. The parity bit is 0 or 1. Similarly, the next parity bit depends on the some P12, P2, Pk2, some combination of zeros and ones. This indicates particular bit I am considering or I am not considering. We have taken in the previous example. No doubt we discuss many examples in the after this theory is over. Copy down this equation. And since Pij are zeros and ones, Ck are also zeros and ones. Even you can write in this in the matrix form. I'll show you in the next slide. Only you have to note down Ck plus 1 equal to P11 D1 mod 2 addition, but it's a XOR only. P21 D2 XOR up to Pk1 Dk. Similarly, Ck plus 2 equal to P12 D1 mod 2 addition, P22 D2 mod 2 addition continues up to pk to dk. So last ck plus n minus 1 it should be, while typing ck n, total will become n minus k. Total should become, number of bits should be n, yeah. So k minus k will get cancelled, cn, yeah, total bits should become n bits. Let me go to the next, how a matrix form we can write. So the way how we can write a matrix form. If bits are 6, for example, I'll take 1, 2, 3, 4, 5, 6, 6. I'll take a identity matrix. 6 by 6 I'll write identity matrix. Followed by I write a parity matrix. Copied on this one example. And using this how we can write equation, or if equation is given how we can write a matrix. That we'll see in the next slide. Example 6 cross 11 matrix, k by k identity matrix followed by a parity matrix. In this we have a 6 cross 6 identity matrix. Identity matrix means all of you know this diagonal I'll be having a 1. Remaining all will be 0. If it is a 3 cross 3, then 1 0 0 0 1 0 0 0 1. If it is a 4 cross 4, then extra 0 0 0 1 will come, like that. If it is 7 and 8, again 1 1 1 will come in the diagonal. So we can write in the equation also using a matrix. So please note down this. Anyway, this matrix is available in the next slide also. Those who have missed 1 or 2 entries, they can see it here also. Now how I can write this is a, this I'll get a code data as it is, C equal to beginning data as it is I'll get. Parity bits, how I'll get? By mod 2 addition of a D1, D2, D3. That only I'm writing. Similarly, second one, I think I have D3, D4, D5, D6. That is written. Similarly, last one I have mentioned. So which one I am taking now? This is a D3, 4 is not there, 5 is not there, D6. D3 plus D6. So if equations are given, you should be able to write a parity matrix. Or if a parity matrix is given, you should be able to write equation. Copy down. Matrix is already with you. Write down this P1 equal to P2 equal to. And learn how to write a matrix form if a P1, P2 is given. Or if a matrix is given, how to write the P1, P2, P3. Take another few seconds and try to complete equations P1, P2, P3, P4, P5 equal to. So another 10 seconds I'll wait and then we'll go to the next. Okay. Now, encoding procedure we are going to discuss without taking any numerical example. And similarly, decoding procedure we discuss without taking any numerical example. Generalized discussion it is. Some students may get some doubts. Don't worry, when you start discussing with a numerical example, you will get 100% you will understand, everything will become more clear. So this I already told you people, information sequence is segmented into blocks of key successive information, and each block I am going to add a n minus k redundant bits. Now let us consider, I let a message d equal to d1, d2, dk, and each bit may be either 0 or 1, 2 raised to k different message blocks I will get it. And code words C1 to C2, these things are repetitive, and rate of the code is a new one, is given by number of message bits divided by number of code bits. This you have to note down, k by n. And systematic block code, first k bit will be data bits. I think these two words, this is the one extra word you can copy down. Remaining you can read it once. Even though it is a repetitive, no problem, because when you read twice, thrice, same thing, you will understand, or these words will remain in your mind. First beginning bits of the code words will be a data bits. Rate of code or code efficiency, they write number of message bits by a number of code bits, k by n. D equal to D1, D2 already is there, C equal to C1, C2 you have copied. Let us go to the next. Systematic means also you have copied. Now the check bits, how we generate. CK plus 1, this also I think you have already copied just now. Glance once. Take another 10 seconds. It is the same equations what you have copied in the encoding procedure. Now, how we can find out a code word? Once if I know the parity bit, parity matrix and identity matrix can be written. So this will become a G. Identity matrix followed by parity matrix will become a G. If I multiply D into Z, I'll get a code word. So please remember C equal to D into G. This I want you people to note down. With a numerical example we are going to discuss later. As of now, a theory we are going to discuss in now. Code words, code bits will be given by a data bits followed by a G. G is nothing but a generator matrix. Generator matrix is given by identity matrix followed by a parity matrix. C is equal to D into G, where G is the K cross N generator matrix and usually it is given by identity matrix followed by parity matrix. Another 5 seconds, I will go to the next slide. Okay, now I want an answer from you people. Generator matrix is given by identity matrix followed by parity matrix, where IK is called as what and P is called as what matrix? Just now I had told. I want 2 words from you people in the chat box. I is called as what matrix and P is called as which matrix? If you have copied also, well and good. Other, even if you are remembering also, you can tell. Identity, very good. IK is identity matrix. Everybody is telling. Very good. Nisarga is telling parity matrix is a P, sir. Cut. So these are the 2 answers. Very good. All of you are active in the class. Let me go to the next. The same thing just I am telling you. If you want, you can note down 1 point. If you are already remembering, so then I will wait for a 10 seconds. Then I can go to the next. I is a identity matrix and P is a parity matrix, and the selection of P matrix decides the properties of the code. So this is about a G identity matrix followed by a parity matrix. So H is a parity check matrix and is given by H equal to P transpose I n minus K. You have to remember H equal to P transpose I. So first I write P transpose followed by I means identity matrix, where P transpose is the transpose of a P matrix and I is the identity matrix. Take a minute and copy down. The H matrix is used to verify whether the code word is generated by G or not. How I can verify? Simply do the CH transpose equal to, it should be 0. H transpose is the transpose of the matrix H. This is about encoding procedure. Similarly, decoding procedure you have to discuss without any numerical example. Once if we complete a decoding procedure, Then we'll take a numerical example. We'll discuss a encoding procedure with a numerical example. That time it will be easy whatever we had discussed so far. Let me go to the next slide. Yeah, decoding of block codes. How we do? A G matrix is used in the encoding operation. H is used in the decoding operation. Consider a block n comma k. G is given by I followed by P, and H transpose is given by P transpose followed by I. Let C be the code word transmitted, R be the received code word. Even though R may be same, but we consider R means at the receiver side, C means at the transmitter I am sending. R is given by code word what we are sending plus some error. E stands for error. There may be error or there may not be error. So just copy down at the receiver side R equal to C plus E, whereas E is nothing but a error vector. And one word you can take down. H is used for a decoding. H is used for a decoding operation. So let me go to the next. R equal to C plus E, you have to write. E is the error vector. C is what? Code vector. Now at the receiver side, what I do, I calculate the syndrome. What is the syndrome, sir? Simply received into H transpose I do. Because I am not doing C plus E. I don't know E is there or not, some error is there or not. Received into H transpose I do, and I will calculate a S. If R is C only, then it will become 0. The same thing is mentioned here. C plus E, R is nothing but. This is nothing but a CH transpose plus EH transpose. But CH transpose equal to 0, all of us we have discussed just now. If E is also 0, then EH transpose is also 0. Hence S will become 0. Therefore, R I can say it's a valid code word. If S is not equal to 0, then I can say E is there, means error has occurred in the transmission. This is about a decoding procedure. Copy down this decoding procedure. We do S equal to R into H transpose. R is a received. Received means a code word plus some error I am receiving. If error is 0, it's nothing but a CH transpose only. Hence RH transpose or S equal to 0. Otherwise I will get something other than 0 S value. Whenever S is not 0, other than 0 is there, anything, any combination of zeros and ones, then I can say some error has occurred. This we are going to discuss with some numerical examples. One by one we will take and we will discuss in detail. Now theoretically we have discussed. Hope most of you have copied. And summary, I want you people to write down these things now once again. This is like a summary. This completes most of the things in this chapter. G is a IP. It is not a multiplication. I followed by P in the same matrix. C is a DG. H equal to P transpose I. S equal to RH transpose. CH transpose equal to 0. Just copy down, write down in your notebook and read it at least 5 to 6 times now. G equal to IP, C equal to DG, H equal to P transpose I, S equal to R into H transpose, CH transpose equal to 0. Hope all of you are remembering. If I tell something, the equation you will type in the chat box. Take another 10 seconds and read it twice or thrice. No need to write H transpose, you can write HT in the chat box. Okay, let us revise. C equal to, can you type in the chat box? C equal to. Okay, Nisarga dg. And H equal to. H equal to. Okay, P transpose I, correct. Okay, and G equal to. G equal to. IP, correct. G equal to IP. And CH transpose equal to. CH transpose equal to 0, correct. And RH transpose equal to. RH transpose equal to. Yes, okay. And S may be 0 or may not be 0. It depends on the whether error has occurred or not. Hope most of you have become expert in these things. And once if you remember this, most of the problems will become so easy to solve. Now let us take one simplest numerical example. Consider a 7-4 block code, copy down. Consider 7,4 block code for which the parity check matrix is given as H equal to. Consider 7-4 block code for which the parity check matrix is given as H equal to. Copy down. 1110100, 1110100, 1101010, second row 1101010, third row 1011001. I repeat, first row 1110100, 1101010, 1011001. This is a H they are given. You have to find all the code words. Take another 10 seconds and try to note down and just go through the equations. Now from this, can I write a P? How to write P? Why should I write P? When I say code word G equal to, so I know C equal to what? Can you type in the chat box? C equal to. Code word I have to find out. So C I have to find out. When I want to find out a C, what is the equation? C equal to D into G. So when I say D into G, D, G. G is a G equal to what? Z equal to, you had already typed earlier, G equal to, yes, G equal to, you just know you have typed IP. Okay, first I, then P, correct. And P I'll get from a H. How? H equal to, all of us know. What is H equal to? H equal to, all of us know. From that I can get a P. Yeah. H equal to P transpose I. So from that I can get a P, and this is a summary you have to remember, you have to recall always. And from this H is given, and now from this, can you say what is the N equal to, K equal to, R equal to? I want you to type in the chat box N equal to, K equal to, R equal to. N equal to 7, correct, Nisarga. And P equal to, K equal to 4, this is also correct. And R equal to is nothing but N minus K. K equal to 4, correct, Vidya has typed. Nisarga is typing 3, means it's R equal to 3. Shankaranand is also typing R equal to 3. All are correct answers. So this is the same thing what you have told I am writing in the slide. Copy down this. K equal to, N equal to, R equal to. H is given. H is P transpose I. G is IP. So I can write down G equal to IP. So what I am doing, row I am making into column, so that I'll get a P transpose of transpose will become a P. Take a another 30 seconds, copy down and try to understand. So those things you have to revise for a few days. Automatically it will become practice for you. G equal to C equal to S equal to H equal to. So it will become easy to solve any given problem. So let me go to the next. Hope all of you have written G. Now G is you got. You can write down C is equal to. C is equal to, I have to write D into G. So D, D1, D2, D3, D4 and identity matrix you can see 4 cross 4, therefore D is 4 and I am multiplying. What I have to do to get a first parity bit, first, second, third bit I have to add. To get the next parity bit, first, second, next bit I have to add. Okay. So D1, D2, D4 or D1, D3, D4 I had to add to get the next. So just observe this, and those who are understanding or those who have completely got the idea, they can write down a C5 equal to. Even by seeing also you can tell, but do it and tell. C5, C6, C7, you can do it. But remember mod 2, don't write 1 plus 1 equal to 2. Remember it's a mod 2 addition. Otherwise, sometimes students will write 3, 2. 3, 2 will never come into picture. Whenever you are going for XORing 1 and 1, you never get 2. That's the one important point which you have to remember. Take a one particular combination D1, D2, D3, D4. Any one combination you can take 1, 1, 0, 1, something like that. Actually, you have to take all the 16. Because it's a beginning problem, you have to do overall. So let me go to the next slide. So what you have to do, so you take D1, D2, D3, D4 starting from 0, 0, 0, 0 up to 1, 1, 1, 1. Multiply C equal to D into G. Find the code word. Type a few code words in the chat box. Your time starts now.